What? What? What color? I don't know. No, not black, purple. Okay. We should be familiar with the simple definition of probability. Like if I flip a coin, what's the probability that I get heads? Sorry? 50%, half, 0.5. You can turn it into odds, 50-50, but we're not really talking about odds. Okay? Express probability as a percent, a fraction, or a decimal. Okay? We use probability simple definition only when all the outcomes are equally likely. So we're not talking about, like if I say, if you roll a single-sided die, what's the probability of getting a 2? 1/6. But, I mean, what happens if it's a loaded die? Meaning that it gets 2 more often than it does other numbers. We're not talking about that with simple probability. Okay? Every outcome is equally likely. So when I flip a coin, there's 2 outcomes, they're equally likely. When I roll a die, there's 6 outcomes, they're equally likely. Okay? Here's another example. 8 red marbles, 12 blue marbles in a jar. What's the probability of selecting a red marble from the jar? And what we usually do is we assign an event or events in a situation with a capital letter. And we use this notation to find the probability of that event. Okay? So the probability of a red, drawing a red, or selecting a red, would be what in this case? 8/20. We do not need to reduce it. Actually, in many cases, it's better not to reduce. It probably makes more sense if you don't. Okay? But you can. I mean, if you reduce this to 2/5, that's fine. Or we could have said 0.4, or we could have said 40%. Okay? The complement rule, that is the probability of some event, let's call it A, not happening. And the notation we refer to the complement of some event is the event letter, capital letter, and then a little c like an exponent, a capital C for an exponent. And it's always equal to 1 minus the probability of the event happening. Because, like, if I flip a coin, the probability of getting heads is 1/2. Well, the probability of tails is also getting 1/2, but you can find the probability of, because there's only 2 choices when you flip a coin. So it's 1/2 to get heads, 1/2 to get tails. They add up to 1. Okay? All the probabilities in a situation will add up to 1. So like when I roll a die, there's 6 different probabilities, 6 different events. Each of those events is 1/6. All those events add up to 1. Okay? So to find the probability of something not happening, we do 1 minus the probability of it happening. So if I were to do, from the example above, the probability of a red not happening would be 1 minus 8/20, which is 12/20. You could, of course, just looked at the question and said, well, there's 12 blue out of 20, so it's 12/20. So there are different ways to find it. Okay? Probabilities. I'm going to change this to from. between. From 0 to 1. It is possible for an event to have a probability of 0. It is possible for an event to have a probability of 1. Okay? What would be a can you think of something that would be a probability of 0? Yeah, you roll a die, and what's the probability of rolling a 7? It's impossible, it's 0, because there's only 6. What would be the probability? Can you think of something that would have a probability of 1?
There's only red marbles. There's only red marbles in that jar.
Okay, so yeah, so like if you had a jar has 8 red marbles in it, what's the probability of drawing a red? Yeah, that's 1. Yeah. Okay. And the probabilities of all possible events add to 1. And of course, it's a percent. From 0 to 1 is 0% to 100%. And if they add to 1, they add to 100% if they're expressed in percent form. This makes, if it has these two properties, it's a valid probability model. Whatever situation we have, all the probabilities in that situation, all the events, their probabilities must be from 0 or usually between 0 and 1. And the probabilities of all events must add to 1. That's what makes it valid. So as another example, we have a bag of 20 beads. They're a mix of clear or solid and red or green. There are 6 clear red beads in the bag and 8 red solid beads. There are 2 clear green beads and 4 green solid beads. Fill out the probability model, which would this be? So what's the probability of clear red? 6 out of 20. Solid red. 8 out of 20. Clear green. 2 out of 20. Solid green. And we want to confirm that this is a valid probability model. This situation is a valid probability model. Well, we would say each probability is between 0 and 1 in fraction form. All probabilities add to 1. So it's valid.
Even like not to like go back on something. You say like in question that each probably mean 0 and 1, you want to like from 0 to 1 or why?
Well, I mean,
Like just the wording is that like the important on the test.
it's minor. Yeah. Could you? I mean, usually when you're checking to see if a probability model is a valid one, those probabilities will be between 0 and 1.
Okay.
There won't be one that's 0 and the other one's 1, because I mean, if one of them is 1, then there's no other ones, are there? Okay. Okay. Couple more questions related to the previous example, which is a valid probability model. R is select a red bead, Q is select a red solid bead. What is the probability of a red solid bead? Selecting what? Well, what's it? 8 out of 20. Be careful with this one. What's the probability of selecting a red bead? It doesn't say whether it's solid or clear. It would be 14 out of 20. What's the probability of not selecting a red bead? Well, you can use this. 1 minus this, which is what? Yes. What's the probability of not red? 6 out of 20, because it's 1 minus the probability of red. I'll put those in. So how does probability work? It's based on the laws of large numbers. Okay. The law of large numbers states that after many trials, the relative frequency of outcomes, relative frequency just means like percentage, okay, will approach its probability. So what I mean by that is, let's say you roll a die, a 6-sided die. Okay. One would think, like, is it realistic to think that for the first 6 rolls, you get a 1, a 2, a 3, a 4, a 5, a 6? Would that actually happen? No. No. What would likely happen is maybe you get 2 1s, 2 4s, a 5, a 3, and then something else. And then the next 6, it won't be a 1 or 2 or 3 or 4 or 5 or 6. But if you keep going many, many trials, okay, it will approach 1/6 for each number. That's what the law of large numbers means. So that, like if you flip a coin, same thing. And this is the example here. And you can see here's how it's graphed. The theoretical probability, what is it? Probability of heads. The theoretical is 0.5 or 1/2. Right? Well, on the first few flips, maybe you get more tails than heads. Or maybe you get more heads than tails. So it could go up or it could go down. But as the number of trials increases, this probability is gradually going to approach its actual probability of 0.5. Okay? So what that actually means too is that probability is unpredictable in the short run, but it's predictable in the long run. Okay? So we would say after many trials, the probability of getting the heads approaches 0.5. Or 1/2, or 50%. Okay? But we don't know that in the short run. So just remember this too. Probability is unpredictable in the short run. Predictable in the long run. when we flip a coin 10 times, finding the probability of heads is going to be a little unpredictable. But if we flip a coin 1,000,000 times, the probability of heads is going to be more predictable. Okay. And finally, just to wrap this sort of intro lesson up, law of averages. This is where casinos make their money. Because you go in and you play blackjack, and you play blackjack for 2 hours and you lose like $1,000. But you've lost so much that you're absolutely convinced, oh, I've got to have a winner soon because I've lost so much. That is non-existent. That is the law, misguided law of averages. So that if you flip a coin and you get 5 heads in a row, there is no such thing to say, well, you know what, because I got 5 heads in a row, it's got to be tails the next time. No. The probability of getting heads or tails is still 1/2 after the next time. It doesn't change. Okay? Like here, you know, look at these two situations where you flip it 10 times and you get a mix. You get 5 heads and 5 tails in situation 1. But in situation 2, you get a heads, 2 tails, and then you get 7 heads. So which situation is getting tails more likely? Which situation? Neither. Because the probability of tails on the 11th flip is still 1/2. No matter, like, a coin has no memory. Okay, we'll leave it at that. Not going to worry about the discussion. I can let you read that on your own.